In this example, we're being asked to integrate 7x minus 3 divided by x squared minus 1. Now, the first thing we have to do, like with any integral, is decide what technique might be appropriate here. Is it u substitution? Is it log rule? Should we break it apart into like multiple integrals? Is it an inverse trig integral? All those types of things that we're accustomed to doing. And one thing that catches my eye about this guy is that it is not u substitution, right? There's not really any composition or layers that we see or anything like that. Unfortunately, it's not the log rule either. It would be great if it was, but and that often happens with fractions like this. But unfortunately, if your denominator is u, then the du would be 2x and not 7x minus 3. Now, if it was just a 7x, we could make it work just by pulling a 7 out and that sort of thing. But the presence of this minus 3, unfortunately, really messes things up. So what are we going to do? Well, one thing that does catch my eye, and hopefully it caught your eye as well, is that this denominator right here factors as x plus 1 times x minus 1. When your denominator factors like that, that's a strong indication that it could be partial fraction decomposition, which means you can take that big expression and decompose it into smaller pieces that you can integrate. And so that's the idea behind partial fraction decomposition. So let's see if we can do that decomposition. 7x minus 3 divided by x squared minus 1. 7x minus 3 divided by x squared minus 1. I'll go ahead and factor it as x plus 1 times x minus 1 because that will help. All right, now remember that decomposition depends on what your denominators look like. If they're linear, then it contributes a certain type of term to the decomposition. And if it was quadratic, it contributed another type of term. These are both linear. X plus 1 is linear and x minus 1 is linear. So this one in green right here would contribute an a over x plus 1. Now, only one term. This guy would only contribute one term. How come? Well, he's raised to the first power. If that was a higher power, he might contribute some extra terms. But I think that's going to be it for us. Right? How about the term in orange? X minus term, that factor. He's linear, and he'll contribute a b over x minus 1. All right, this is what I like to call the template of the decomposition. It's what your decomposition will look like, but the details aren't filled in. Now, what details am I talking about? Well, namely the a and the b. Right? If I knew those, then that would be a perfect decomposition of this expression. All right, so hopefully you've watched our other videos up to this point, and you know already how to proceed from here. If we're going to use the shortcut to find the a and the b, here's how we go about doing that. We're going to multiply the lowest common denominator, which is x plus 1 times x minus 1, to both sides. So the 7x minus 3 is all you would have on the left-hand side, because x plus 1, x minus 1 would cancel. If you distribute the LCD to these two terms, the first term would give you an a and only an x minus 1 because the x plus 1's canceled. And then this would give you a b with an x plus 1 because the x minus 1's canceled. All right, so hopefully you understand what we did there. We took this guy and we multiplied him to the left side and the right side. On the left side they canceled and gave you 7x minus 3. And when we distributed this term to the right hand side, the first time the x plus 1's canceled, the second time the x minus 1's canceled. This is an identity. This isn't a typical equation that has a right or wrong answer for x. This should hold for every x if this is truly equal to this decomposition. So we're going to be smart about it. We're going to pick certain x's that make either the a or the b go away. Okay. So, for instance, if we wanted the a to go away, we could let x be 1. And 7 times 1 is 7. 7 minus 3 is 4. And that would be equal to, this would be 0, right? That would be 0 if x was 1, plus b times 1 plus 1 is 2. So 2b bam, that automatically tells us what b is. B is 4 over 2, which is 2. All right, keep that in mind. Now, what would be the x value that would make the b go away? Well, I think x would need to be -1, right? So -7 minus 3 is -10. -1 minus 1 is -2 times a. And so in this case, a would be 5, right? 5. So there's your a and there's your b for the decomposition. So let's go back to the integral now. And rather than integrating this expression in white, we can integrate something a little bit easier, right? Let's write the decomposition out. That integram was the same as a over x plus 1, which is really 5 over x plus 1. Let's see. Then we have b over x minus 1, which is in effect 2 over x minus 1. 2 over x minus 1 dx. Okay. And here's a simple question for you. Would you rather integrate this, or would you rather integrate these two individual terms? Obviously, we would say the two individual terms. Is much easier, much more straightforward algebra to integrate these two guys. They're both the log rule. There's honestly not even a whole lot to write down. I think we can just go ahead and write our answer down. We can break this apart into two integrals. The integral of this expression plus the integral of this expression. We could pull a 5 out of the first integral. Now 1 over x plus 1 dx, plus we can pull a 2 out of the second integral, and we'd have 1 over x minus 1. This is a log rule and this is a log rule, and so we're done. This will be 5 times the natural log of x plus 1 plus 2 times the natural log of x minus 1, plus c, of course, because it's an indefinite integral, of course. Okay, and that's it. I mean, this is a very typical partial fraction decomposition problem. You're asked to integrate a big, ugly rational expression. You break it apart using decomposition like this, right? Find the a, find the b, find the template, all that kind of stuff. And these two individual terms will be easier to integrate.